Task Force on American Innovation. We are really delighted to have you here with us today, and I think we have a great program. And before we get into the program, what I'd like to do is say a few words about the task force and also thank the House Manufacturing Caucus and Congressman Tim Ryan for being with us and helping us sponsor this event. So the Task Force on American Innovation is a group of nonpartisan group of companies, trade associations, universities, and scientific societies. Obviously, that's a pretty diverse group. And we come together for really a single purpose. And that purpose is to support federal investment in scientific research. And the reason for this is really pretty simple. In the 75 years since the end of World War II, the United States has created the most dynamic and advanced innovation ecosystem in the world. And the rest of the world has been watching our playbook, seeing us advance scientifically and technologically, and becoming the world's leader in these areas. And so the rest of the world said, wow, we'd like to enjoy the same benefits that the United States has been enjoying. And so they've begun to do the same thing that we've done, which is to bring together industry, academia, and government in innovation ecosystems. And so what's happening today is that the leadership that the United States has enjoyed for many years is being challenged by other countries around the world. And if we want to stay ahead and lead and create jobs and economic growth, time has come for us to redouble our efforts in scientific research. Let me talk for a little bit about research itself. Primarily, the federal funding for research is in basic and advanced research done at universities across the country. Private sector research is primarily development, engineering, manufacturing, and the commercialization of these ideas for products and services that enter into our economy. So private sector research and public sector research are really different, but they're very complementary to one another. These are two engines of growth that work together to create the economy and the technology and the leadership that we all now enjoy. I think it's really important to understand that this federally funded research is really the primary source of university-based research in America. And the output is pretty clear. It's the creation of new ideas and highly educated students who ultimately become highly educated workers in great jobs, highly paid jobs, and create economic growth for all of us. To paint a full picture of this R&D portfolio, I recommend to you the report that the task force published earlier this year in May. We call it the Benchmarks Report for Second Place America. And the question is, do we want to become second place America? And we think the answer to that is absolutely not. So we have copies of the report out on the table. I ask you to pick up a copy, take a look at it, and study the numbers. It's really clear what's going on. But rather than me talking about this in sort of broad strokes, what I'd like to do is introduce Congressman Tim Ryan, who's the chair of the House Manufacturing Caucus, and allow him to make a few words. And I'm very happy to hear you.
Thank you so much. This is very exciting. We are and have been for a long time having conversations in the manufacturing caucus about the future of manufacturing, the future of work, about collaboration, about building these innovative ecosystems that are needed. And we're very proud to have landed America Makes built around additive manufacturing, and is our institute in Youngstown, because as we talk about the beautiful thing about the institutes and things like 3D printing is, one, the 3D printing additive manufacturing affects so many different industries. And the other thing is that these institutes really have an impact in the local community as well. So it's national, it's global, it's innovation, it's partnerships across sectors, but it's also having an impact to redevelop some of the local communities like we've seen in Youngstown, Ohio. I want to thank the Task Force on American Innovation for hosting and coordinating this briefing. I want to thank John Wilczynski, who's the Executive Director here of America Makes since June. Still fresh, still ready. He was previously the Deputy Director. We're seeing the impact of federal funding on advanced manufacturing in general, and particularly in additive manufacturing. It's been a tremendous impact, had a tremendous impact, and continues to expand. The Manufacturing USA Institutes is 14 overall, have attracted $304 million in state and private investments. As the report probably shows as well, that we're in a stiff competition with China. They're putting a lot of money behind these newer technologies. They have a Make It in China 2025 plan around all different sectors of the economy, aerospace, wind, solar, everything else. One of them is additive, that they're putting a lot of money behind, and it's hard to tell because it's China just exactly how much money they're putting behind it. In fiscal year 18 alone, we've had over 200,000 students participate in institute projects or internship programs or training, so we're also using this as an opportunity to build the pipelines with the level of collaboration we have. We're proud of what's happening at America Makes, but it's key to have the federal funding. It can be seen all over the ecosystem that's developed around America Makes, partnerships with Youngstown State University for research, Youngstown Business Incubator for business development, small and medium-sized businesses, and the Air Force for implementation of advanced manufacturing. And it's working with the Air Force to improve sustainment operations, transitioning to advanced manufacturing technologies, including additive manufacturing. They're going to yield great results. And we're already seeing some studies come online where the military is going to be able to save a lot of money. So I think this particular technology is important because it could meet the priorities of both political parties. How do we begin to drive down some of the costs in the Department of Defense? But how do we do it faster, leaner, more efficiently? How do we do it in a more environmental friendly manner, using less materials, and not needing as much fuel, for example, if we can trim off some of the pounds of a plane. One challenge in additive manufacturing is having standards, and America Makes has brought 175 public and private sector organizations together with the American National Standards Institute to develop standardization. And we have a few pieces of legislation that I'm promoting. We would obviously welcome any support here. One is the Incubator Act of 2019, which will pump about $600 million over the next 6 years into business development and economic growth through support for incubators, and funds will be distributed throughout the United States. Brookings Institution came up with a study, or had a study a few years back, and it said businesses that come out of an incubator locate within 5 miles of the incubator. So these incubators are a great opportunity for us to put them in communities that need growth, that need innovation, that need jobs and development, because more than likely that business is going to spin out of there, is going to locate within that community. We have a bill for a chief manufacturing officer in the United States, which requires the president to appoint someone with the right background to take American manufacturing into the 21st century and really have it as a focus. We have a Strengthening Investment to Grow Manufacturing in America Act, which increases affordable loans to manufacturers, provides incentives to grow operations, support manufacturing startups, and expand education assistance. And then lastly, the Retain Act, which adds a preference in civilian and defense contracts for contractors that promise to retain jobs in the United States. So we've got a big agenda. I think this can be transformational. I think it can be bipartisan, and it can push America really deeply into the 21st century as a leader around this issue. As I said, China's doing this. China's dominating electric vehicles. They're dominating solar. They're putting a lot of money behind additive. They have focus and a strong industrial policy. This is our attempt to try to do this here in the United States, and it shouldn't be a partisan issue. So we welcome everybody's support, and I appreciate the opportunity and look forward to the dialogue here today. I want to welcome all of our guests. Thank you.
Mr. Ryan, thank you so I couldn't agree with you more, that the moment is now. We really have to act because our competitors have read our playbook and they're putting their money where their mouth is. So we have a really great program. Rather than me talk about it, however, what I'd like to do is introduce Dr. Mark Johnson, who comes to us from Clemson University. Dr. Johnson is going to lead the discussion, moderate the discussion, and introduce the speakers. So, Mark?
Thank you, and apology in advance. I always have to tip the microphone up. So, welcome. Thank you for joining us here today. I'm Mark Johnson, I'm a faculty member at Clemson University, director of the Center for Advanced Manufacturing there. And we're going to have a discussion today about additive manufacturing, and I will say our panelists are probably in a better position to actually share their stories than anything. The message that I want to share with you all is that this is an overnight success, additive manufacturing. They seem like great breakthroughs that are happening. It's an overnight success that literally is decades in the making. It is decades of investment in research and development using our public taxpayer dollars for this that has made it possible to move forward. And as noted, the moment is right now. This is an international race where you want to, if we don't seize upon this opportunity and continue making those investments, that previous investment will essentially be gone. So how do we keep pushing this forward is what we want to highlighting. And a step beyond that, by doing a lot of that additive manufacturing research that's going on, commercialization, technology development, it's opening up actually new scientific questions that motivates that investment now of new seed corn that's going to pay dividends for decades ahead. So hopefully our panelists will wind up sharing some of their stories on that. Our keynote speaker today, we're going to have Joe Beeman, and wind up going to introduce him in a minute. But I'm going to give a look ahead on who are some of the panels we wind up having and how this winds up reflecting that mentality. First is Randy Adams. He's the Vice President of Engineering, the General Manager of the CNC Table Products at Cincinnati Incorporated. They're a manufacturer of large area 3D printing equipment in Ohio. So they actually make the equipment themselves. For those who don't think that you make these tools in the United States, you're wrong. We make them, and you have companies that are fighting them. Randy will share with you that their company got into this field recently through cooperative research and development agreements with the public sector, with national labs, with universities. So that investment winds up paying off on that. Next speaker we wind up having coming across is we have Professor Allison Beasy. So Allison's an associate professor of material science and engineering at Penn State University and does a lot of research into the mechanical properties of materials and understanding the fundamental science that you wind up needing to not only make these products, but actually use those products. How do you put them into practical products that are out there, and developing that work in the industry. A key point to look in her background is she was as a faculty member invested in by the National Science Foundation as one of our career award recipients. And these are the faculty members of the future where we've identified the most promising talent across the country and making sure we're investing in that. So Allison represents that really well. Craig Blue is the Director of Energy Efficiency and Renewable Energy Programs at Oak Ridge National Laboratories, and really has been the driving force behind something called the Manufacturing Demonstration Facility at Oak Ridge that is really looking at pushing additive manufacturing into new areas, leveraging that investment we've already made in the national laboratory system. A key thing is the investment that the government's made in Craig, in that his graduate school was actually paid for by NASA and doing work at the NASA laboratories in Cleveland throughout his graduate school itself. And we also have John Wilczynski. John's the Executive Director of America Makes. This is the Additive Manufacturing Research Consortium and Technology Development Consortium located in Youngstown, Ohio. He really pushes forward and wind up connecting that public sector investments we've already made with the private sector and bringing that as a consortium. We're answering a range of questions that companies have as they're moving this technology forward. So that's the perspective John wants. So that's our panelists. Our keynote speaker before that was going to be Joe Beeman. Really, Joe is the godfather of additive manufacturing. Has sort of brought this forward since the 1980s and 90s, and seen the entire arc of development of this technology technology with 3D printing and where we've had public sector investment of different levels throughout that time. The professor at UT Austin, where he's done this work and has a lot of accomplishments across the way, but I'm going to actually point out not only the investment that the National Science Foundation made in his research, but in his graduate students back at that time. Carl Decker was one of the first early graduate students that worked on this, and I think he was one of the first graduate students working on 3D printing. I knew Carl in the summer of 1979 when we were both high school students, and we attended a National Science Foundation summer camp for students that were interested in physics and computers at Drake University in Des Moines, Iowa. I actually have the photo of the campers to prove it, including all of the wonderful fashion that we wanted to have. So Carl liked the cowboy hat at the time. I'm clearly not showing that picture. Anyway, but this points out that we wind up investing an entire lifetime of people in developing that scientific and technology infrastructure that we need to move a technology like additive manufacturing forward today. And we need to keep making that investment going forward. So with that, Joe, turn it over to you.
Thank you, Mark. I did look at that picture. I have some pictures of me too, so really thank you for inviting me to this. I consider manufacturing extremely important. In fact, the most important thing we do. Of course, I'm biased, but that's how I believe. And I should title this really my personal history. I'm not going to try to give you all the history in 15 minutes. I'm going to tell you what happened to me anyway, and also how the importance of federal funding was to making that happen. And so I'm going to show you some slides. By the way, these are originals. This is from 1986. This is what a computer looked like in 1986. And this, by the way, is an object that we built that used to be a mathematical equation. We turned it into a surface model and made it. There was actually no CAD for this at all. And this is what we called 3D printing at that time. We called it solid freeform fabrication. We wanted to make complex freeform objects without basically right from the screen to the object immediately. Now, by the way, we haven't quite done that in everything yet, but we're getting darn close to doing exactly what we're saying. This is a concept that we said, well, how are we going to make this happen? We coined a term called voxel manufacturing, where you would have little volume elements rather than pixel elements, where you would have support voxels and you would have structural voxels. And the big takeaway from this one is what we're really trying to do is, why does it take 6 months to make the first one of these? And usually it's, by the way, not the machining time. It's someone has to make fixtures. You have to get in line to get to the machine shop. And we want to be able to just push this button and make a part. And so this is the piece of equipment that became commercialized. This is not where we started. I'll show you where we started here in a minute. We started DTM Corporation in the late 1980s. This is the first commercial rendition that we actually sold. In fact, our first sale was to a national lab, San Diego National Lab, bought our first piece of equipment. It makes parts. You might have seen this. If you don't know how these work, you basically take an object, and in the CAD software, you can actually do a slice across that. Let's say I'm making a glass, which probably you wouldn't want to make a round glass this way, but it would be a circle. And I basically make a circle, but it has not only two dimensions, it also has a third dimension where we're attacking, actually melting different volumes next to each other. And so by that, we actually create something that's very complex shapes. And so this is, by the way, what it looks like when you first start. Okay, I hesitated actually showing this, but this is what it really looked like. So we made these parts. We were trying to sprinkle them. We thought we could sprinkle powder down, and that would be our layers, right? And we were scanning at the same time. And this looks a little like a snowdrift, because that's what happens when you sprinkle powder down. So it didn't take us long to figure out that we better make flat layers. In fact, so it seemed like it's pretty simple, but the concept is simple enough in itself. But if you don't make a flat layer, you don't make flat parts. And once we did that, and we also, the thing else we discovered pretty quickly is you don't heat the substrate, you make potato chips. So if you hit this thing down, we're hitting it with a laser, it gets hot on the top, and when So essentially, we have to put this in a thermal environment. And so this is Carl. So I thought I'd show you this. I think this is working. This is a piece of equipment that drove a leveling system back and forth. And here it is scanning. And I will give $1. Anyone knows what this is? Anybody know what this is? That's called a Commodore 64. Anybody know what a Commodore 64 is?
Oh, yeah.
64 kilobytes of memory. Okay, that was a personal computer. And that's what we drove our system with. And that's Carl and that's me, so it's a little different. He wasn't wearing his cowboy hat. We did make parts fairly quickly. This is in the late 80s. We made metal parts. We made copper parts. I thought I'd show you one thing that's kind of interesting. We actually made some pretty exotic things. This thing that says hydroxyapatite, that turns out to be artificial bone. And we thought we could print down bone that would be structurally sound and then implant those for medical reasons. We did some rabbit studies with the company, and we actually could do it, but no one's actually quite commercialized that yet because if you have any flaws in the part, right, you got a problem. And so we have to make parts that are flawless. I'm going to talk a little bit later. This is a piece of equipment that we made a little later. It was 1998. We were actually making titanium parts, super alloy parts. This was with Lockheed Martin, or Alloy back then. We made, it wasn't the first metal part. We made some of them earlier. But the important part here is we made a mil-spec part. If you know what a mil-spec part is, it's a part that's qualified. It has all the structural constraints that you could put this in an aerospace device. And I'll talk a little bit more about this. Let me talk a little bit first, though, about the company we founded. We founded in about 1989. Started by Carl Deckard and students and me and entrepreneurs. We grew to about 100 employees. We're about 25 million in sales, and then we were bought out by 3D Systems, which is a U.S. company, by the way. A little bit of the kind of the abbreviated funding, what made all this happen. This would not have happened without federal funding. We got what's sometimes called a sugar grant, but it was the first funding we got. And a sugar grant is where you go if no one knows what you're doing yet. So we had to explain things, what we were actually trying to do, because no one actually was doing this yet. And we talked the NSF, our program director there, into giving us, I think it was $30,000. That was basically our sole support for at least a year, provided Carl's funding. By the way, $30,000 went farther than it does today. So that was, and then we also got, some of you may be familiar with SBIR programs. And so the company, which was Notable Automation at that time, it became DTM, got one of these. And it provided really all of the initial startup costs for that company. It was critical. We actually won, I think, the second phase of it, but by that time we'd been funded by B.F. Goodrich, and they decided not to do it, so we didn't go for the second phase. Another piece of work was low-cost metal processing. That was O&R. That's what funded the mil-spec parts. And then I thought I would mention one thing. We actually wrote another proposal which got rejected. So I said, it's never hunky-dory here, don't get everything you like, right? So we actually had a proposal for what's called an engineering research center. We got all the way to Final Four, but it was about making, could I put down precise applications of energy and materials, different materials in different places. And as some of the panelists know, that's a hot topic for research today. In fact, we still don't know how to do it. I'm not sure if we'd have got it if we had figured it out, but we knew how to propose it. So I thought I'd give you a little bit of the timeline real quickly, just so it knows you how long it takes to do things. So we started this thing in about 1986, and in 87 we developed the machine. Then by 88, we kind of formed a company, but it was very, very basic. They didn't have any funding at that point. By '89, though, we did sell some parts. By 1990, we made kind of experimentally the first direct metal parts, so things moved on pretty quickly. And then we sold our first machine, San Diego National Lab, as I mentioned, in 1992. And then you start seeing some much longer time frame, because as you get into technology, it takes longer and longer, especially if you're trying to make parts that people rely on. And so in 1998, we made the first mil-spec part. And what I want to mention here, we didn't actually do this, GE did this, but they saw our research we did with Ralph Watt, and they started working on making parts for jet engines. Well, not directly, how to make parts for GE Aviation, would be a better way to say this. And Dave Abbott said, he saw our presentation, and he said, well, I think we're going to start working on it. And by the way, in 2017, that's quite a lag, right? But they are now flying parts in jet engines. And I think it's the first part that's gone into a jet engine. There have been other parts on airplanes, by the way, not wings, don't worry. But they're like ducting for aircraft. So I want to say, this investment that you have made, or this country has made, sometimes takes a long time to come about in terms of commercial parts. I do want to mention some critical innovations that happened in the 1980s, which are also not directly to me, but if they hadn't happened, then we couldn't have done it. And one was lasers. Now lasers have been around for a while, but they cost a lot. And so right about this time, because of investments, research investments, laser prices started dropping. It's because we needed a laser. Laser is very important because it has both energy and information. It has the geometry, as you scan. And if we didn't have that, we couldn't have done what we did. The other thing that came about at the same time was solid models. A solid model was needed so I could slice it. I mean, I was still at the age where you did everything on paper, right, and blueprints. By the way, I hated those courses. But, so I really loved solid models when they came about because it made it capable for us to slice these parts. And the last thing, if this hadn't happened, you might not remember this or not, but the PC wasn't around that long. Because we had a lot of computation we had to do in real time. And if that PC wasn't there, we could not have made it. And these were all things that were funded by the federal government. I do want to mention just a couple of things. We're not done with this yet. I thought I would talk about OCT. All it is medical imaging. You say, why am I talking about medical imaging? Well, what's interesting about medical imaging, it actually sees down into the third dimension. And one of the real problems still today with additive manufacturing, how do I guarantee I don't have flaws on my part? And so what if I could look at every layer, I'm not just the top of the layer, but actually look down into the layer and see if there are any flaws. And so that's some funding we have today. And so we've actually built a system based on OCT, which is not developed for us, but we've used it, and that's being funded by the Air Force today. I should just mention a couple other things, and then I'll step down. I think it's an exciting field, but it's not over yet. We've got a lot to do yet, especially in process control, because if you're going to fly parts, you better be darn sure that they're not going to fail. Okay? And so there's a lot of issues yet, but I do want to thank. These are all, I didn't get a chance to talk about all these funding opportunities, but we got funded. By the way, I was a PYI too, it turns out. I actually used that, I forgot how to use that money for actually doing this work. I didn't actually tell myself that. I did. And then NSF, Office of Naval Research, DARPA, Air Force Research, and also Army Research Lab. So thank you, funding agencies, and you're a big part of what we have. Thank you.
All right, thank you, Joe. Really appreciate that. And I think it's interesting how many people that are moving forward in some of these technologies had their early careers invested in. So, first of all, thank you to federal agencies for that as well. Okay, this part of the event, we're going to spend the next sort of 20-25 minutes going through on a panel. We're going to explore additive manufacturing as an example of technological innovation in the United States, different efforts of it, and how that long-term federal investment in research and development has been essential to breakthroughs in technology impacting manufacturing today. And I look at around three issues. One is that issue of those years of federal investment built that foundation around 3D printing, as we've heard. how today's federal investment is really leading to the opportunity to take on these applied research and development challenges that are impacting manufacturing in the near term. We're in a global competition. If we all take our eye off this opportunity, people are going to wind up passing us. We want to wind up turning that investment we've made into economic growth. That means partnership with the federal government. And then the third issue really is looking at how today's innovations then open up new questions that were not even asked 30 years ago. That opens up opportunities for more investment, new science, research, and development that's really going to build that bright economic future for us all. So I'm going to take turn with each panelist, give them an opportunity to provide a brief description of their own work, how that winds up fitting into some of those themes as well. And panelists doesn't need to cover all of those themes themselves, but really give a sense of how in their organization and how they work that has moved forward. I'm going to start with Craig Blue here from Oak Ridge National Labs. So, Craig.
Thank you, Mark. Everyone can hear me. First of all, I'd like to thank you for having me at this event today. Clearly an exciting area. Myself included, started at Oak Ridge 25 years ago working with MIT, developing an inkjet metal printer. So I have deep roots in this as well. So the manufacturing demonstration facility, I'm going to spend the next couple minutes describing, it's a public-private partnership funded by DOE's Advanced Manufacturing Office within the Energy Efficiency and Renewable Energy area. It's the first premier DOE user facility established to provide open access to industry for advanced manufacturing infrastructure, key staff, and tools in the areas of additive manufacturing, composite, machining, and digital manufacturing. The one thing I'm going to stress, this environment where we have different people with different backgrounds working together is really key to success. And so it's much more than just additive, and we'll talk more about that as we go. The MDF was started in 2012. It was originally a 45,000 square foot facility with this whole concept of looking at public-private partnerships around the world and then how do we make it work here in the United States. We've had tremendous success. We're now moving into a 110,000 square foot facility. We presently have 70 dedicated systems. Some of the parts you see here today, Randy from Cincinnati, one of our critical partners, he'd like to have brought a part, but it'd be about the size of this desk. It's amazing how far additive it has come. Within MDF, you have industry, academia, other federal agencies, consortia, and other laboratories having real access to distinctive capabilities, actually 6 of them. Large-scale metal additive manufacturing, composite and polymer additive manufacturing, metal powder bed. Most of what you see here is metal powder bed. Machining is still a key part of additive. The ultimate goal is to not have to machine, but in many circumstances, machining is necessary. Metrology and characterization, this is what was just spoken to, really key to qualifying parts. You want to qualify the lot size of 1. And then manufacturing analytics and simulation. Really the rise of data is real key in being able to qualify these parts. So provide users access to these facilities. We're able to accelerate discovery and adoption of technology through enabling energy improvements, U.S. competitiveness and new products, and we'll talk about that as we go, companies that have spun out. Actually, the one far to the right is Volunteer Aerospace that makes this is spun completely out of the MDF. And then really accelerating this innovation ecosystem by working together. The MDF typically does about 4,500 visitors a year. Of that, 500 of them are companies. We just surpassed 28,000 visitors to the facility. This is a real key element of the MDF. Some of the best ideas come from our partners. I always like to say 80% of the solution is typically given to us by the partner. We help with that last 20%, that 10%. It may be that we're bringing our scientific tools to bear. Oak Ridge has traditional strengths in advanced manufacturing, advanced materials, computation, advanced characterization, neutrons being highly penetrating. We can confirm models and things of this nature. So it's really key. We typically do about $100 million of CRADAs at any given time. Over half of that is provided by the industrial partner. In fact, the proper research and development agreement has put forward the industry funds their side and then DOE funds our side. The federal investment is really enabling this. In many instances, as I mentioned earlier, 2/3 of the equipment sitting on our floor is actually the industrial partners. And like Cincinnati has 2 machines on our floor. So that's a real critical element. We've had 92 industrial fellows. As I mentioned, we actually had industry come in and work side by side with us, stay with us for an extended period of time. We work with over 50 different universities. We've had over 1,000 internships and students. It's really a beautiful opportunity for these young people to be exposed to not only the advanced science and technology, but the companies they'll ultimately be employed with. We've had about 131 awards, 27 R&D 100 awards, 14 just since 2012. We typically do 50 to 100 peer-reviewed publications a year, and research has resulted in about $1 billion of follow-on investment. One of the key ones that we always highlight, we've worked with RCAM out of Sweden. They were the only EV powder bed system in the world, and they were 9 people when we started. It goes back a few years ago. As we evolved that at Creta, they had 30, 40 people in the country, and then ultimately were acquired by GE for $650 million. We have another partner that was acquired for over $600 million. So really key to what we're doing is trying to accelerate this innovation, have real impacts, and move it forward such that we can save energy and help with American competitiveness. So thank you.
Great, thank you, Craig. Well, I know working with the MDF, and I've followed you guys for years, Randy, you're a great example of a company that's gone into that environment as a real manufacturer with real manufacturing problems and profit loss every quarter you have to answer to. What if you could share with us sort of your experience in pushing forward additive manufacturing, how this changed when you worked with your company?
Well, we've had an excellent experience with the MDF. In 2012, right after the Great Recession, we had a new executive team come in, and they came in to me because I'd been there for so long that the dirt was starting to have my name on it, and they recognized that. And they said, what do we need to do to come up with a new technology? And we had visited Oak Ridge a year prior to that, and I said, well, that additive manufacturing looks really cool. It's basically our laser with a thermoplastic extruder on it. And our laser, we make a laser that has a cutting bed, that we have 3 cutting bed size, 5 by 10 foot, 6 by 12 foot, and 8 by 20 foot. And we could supersize that. But we need help because there's material science in it, there's knowledge that we don't have in the metal fabricating business. We're a 121-year-old business, family owned in Cincinnati. And we're not Cincinnati Millicron, by the way, we're Cincinnati Incorporated. But we had a lot of wealth of experience in metal fabricating, but we didn't have anything in thermoplastics. So we reacquired a relationship with MDF and went down there, visited them again. They came up, and Dr. Lonnie Love, he walked into our laboratory and said, man, I gotta have one of these right now. I want one tomorrow. We were able to establish our first Creta with them. They took our machine, we took all the laser top works off, we shipped it down to Oak Ridge, and I think we shipped it in February, and by May they were printing parts on it. A collaboration with another company called Local Motors, some energy came out of that. That following September, we did a car, the electric car with Local Motors called the Stride, and that launched a whole new business division for us. In that time, we've increased our employment, which you're going to say, well, it's not really much, but for additive manufacturing on a company that has sales north of 100 million, we added 3% of our workforce is added strictly to additive manufacturing. We've recently purchased a company in Boston called NV, or New Valence Robotics. They are owned by us now, so we have a small machine that is much like that. We call it a desktop printer. We will be releasing a new machine at FabTech, which is our big trade show for the metal additive, or excuse me, the metal fabricating side of our business. That's in November, and it's a MAM-sized machine. We've hired software engineers, we've hired salespeople, we've hired mechanical engineers, and we've hired applications engineers for additive. So we've grown our business because of the additive, and we are now international. We've sold a machine in Mexico, and we have sold one in China. We have approximately 12 machines in the field. 2 of those are at the MDF. We have academic partnerships. We have a partnership with IACME. We have a partnership with American Made. We have a machine at NIAR, which is at Wichita State, University of Texas, El Paso. And we have also created a service bureau that we have out of our facility, and I've added people to our workforce that we print parts for hire. And we're doing two things with that. We're taking the technology that the scientists at Oak Ridge developed, and we're turning it into a commercial product, because we're not a big enough company to afford the R&D dollars that it takes to create things from the ground up. And that's the one thing that I remember as an entry-level engineer when we started. We came out with the first linear motor laser cutting machine in the United States. And we had 5 or 6 years of cutting with a ball screw driven machine, but we wanted to come out with something that was super fast. And I remembered the pains that we had in doing that, and I was able to use that experience and know what the MDF had, and we were able to leverage that. So we basically took a concept car and turned it into a viable product that we're selling in the marketplace internationally now. So I think our partnership with Oak Ridge has been twofold. Number one, it's broadened our horizons, got us into new technology. One of the things that we were dealing with was the stodgy economy, the old Cincinnati Incorporated. Now people know us for additive manufacturing. When we hire young people now, we say, oh yeah, we've got additive manufacturing. And they say, well, I've been doing that since grade school. I've been doing it since I was 58. So it's broadened Cincinnati Incorporated's future, and it's put us on the map. And all of that is because of our relationship with Oak Ridge. All of our customers that we have in Additive at one time visited the MDF either with somebody from our company, or they were down there and the MDF said, yeah, Cincinnati's commercialized this, see that. And finally, the last thing I wanted to say is that we are in the private sector as well as academia. The Cola Motors, TSI, Mexico, they make portable security equipment systems that they're on bodies of trucks, and they use those to make the shell that goes on the trucks. And then I think I recently talked about Textron Aviation, Lockheed Martin, and a company in Akron, Ohio, which was a startup company called AES, Additive Engineering Solutions. They actually have 3 of our machines now. So as you can see by our partnership with the MDF, Oak Ridge National Labs, we were able to, in basically 5 years, come up with a new business model, which quite honestly, I would say that if we were doing that on our own, it would probably been a 10, 15-year process, just based on my experience in the laser. I've been around there long enough to see our technology changes, and I think 10 years would have been a fair assessment just to get to where we are today. Are we done? No. And this Friday, we're working with Oak Ridge on our 3rd grade. That's all I have.
Tremendous. Thank you, Randy. And I presume all these international companies, I love that you're commercializing and manufacturing products here. I'm assuming that checks are coming back into the United States for things made in the United States as a result.
Yeah, because I wouldn't be here if they weren't.
Yeah, exactly. And that's fantastic to see. You touched on something at the end, AES up in Akron. I actually went to the ribbon cutting when they installed their first machine up there. This is 2-3 years ago. It was interesting. I don't know how many people have been to Akron, but in that area, there's a manufacturing area on the north side of town where you have a number of machine tool companies and various companies in the area. And often these are family-owned businesses. And in fact, that startup company was started by a young man who'd been down to the MDF facility at Oak Ridge, was working for a different company, said, I need to start a company. He went back home to his uncle and his father, who had a small manufacturing company right next door. They said, we'll make an investment in you, we'll see what winds up happening. Going to that ribbon cutting was phenomenal because an entire group of manufacturers from Akron came by to see this company. They weren't involved in 3D printing. They came to see this company because they said, this is providing an opportunity for the next generation of students, of their families and the businesses to take a technology, start companies, take that risk, and really do manufacturing, and that's phenomenal what we're seeing. And you're seeing that across the board, and our next speaker, Allison Beasley, I hope you can wind up commenting on this. I know I see that at Clemson right now, that students walk into a facility where there's additive manufacturing equipment, and they go right to it, and they just go to town on it at this point. And it's really getting that next generation going. I wonder if you can comment a little bit on what's going on at Penn State and how that winds up tying in.
Yeah, definitely. Thank you. So at Penn State, my group researches on additive manufacturing but of metals, and so we're focused on understanding the fundamentals of, can we print parts that are reliable? We have particular strengths that we need, ductilities that we need, and we want to be able to use these. And so, but there's a lot of fundamental science that needs to be basically understood before we can adopt them. So there's nearly all industries have the potential to be impacted by additive manufacturing. So you can think about biomedical and customizable implants, lightweighting, so aerospace and automobile companies, also replacement of parts and just design in general of very complex shaped components. But in all of these cases, you have to be able to say that we certify that they have particular properties and they can be used reliably. So that still requires the fundamental research to be done. And so my lab has been funded by NSF and ONR and through some SBIR programs as well, and that's really been fundamental in terms of performing the research, but also educating the next level of the next generation of scientists. So through academia, we're naturally educating and mentoring undergrad students and grad students that come through our labs. And these students will also go on to industry, maybe make their own startups, go to grad school, national labs, or academia themselves. And we have a couple of unique things at Penn State that are working towards educating the workforce. So we have a Center for Additive Manufacturing called SIM3D. So that stands for Center for Innovative Materials Processing through Direct Digital Deposition. But anyway, it's a center. It was initially funded by DARPA. It's a collection of equipment, metals fabricating equipment primarily, but we also have polymers and ceramics. And it's also a collection of faculty, and it's a teamwork also with the Applied Research Lab at Penn State. So there's a lot of people involved, there's a lot of equipment, and what we do is we work on fundamental research, but we also go to reach out to the additive community as well as primarily the additive community. So we have an industry practicum that we run that has educated over 300 practitioners and program managers where they come in and they get hands-on experience. At Penn State, we also started in 2017 the first Additive Manufacturing and Design Master's program. And so this is specifically designed to address the multidisciplinary aspects of additive manufacturing. And one unique thing about this is we have a residence and online program for this. And so far in the 2 years, we've had over 90 participants from over 30 companies. So companies are sending their employees to this program to get that understanding of all the aspects of additive manufacturing so that they can adopt that and advance it in their own companies. And there's also hands-on components of that. And so not only then, so the fundamental research obviously directly impacts this undergrad and grad students, but it also has implications for other businesses as well. So you think about it to manufacturing, and you think also of this increasing business for supporting technology. So this means that you have, if we're talking about metal additive manufacturing, you have metal producers. So steel, aluminum, titanium companies are impacted. Their work increases. Powder metal companies, so creating the powder metal that we use in these machines from bulk materials is another technology. You have afterwards, you have machining, as alluded to previously, as well as heat treating, and then there's a number of startups that then also sort of come out of this. And it also, as you alluded to previously, opens up new research areas. So you think about, okay, we're using additive manufacturing with steels or titaniums that we know, but there's also an opportunity for design of new materials and multi-materials. There's also machine learning as being adopted and artificial intelligence in terms of trying to say, okay, what are the links that we have when we're actually fabricating something? What can we learn about that process? And big data as well. So trying to kind of harness some of these new areas and provide a new application space, and then multi-scale and multi-physics modeling as well. So I guess I wanted to convey that, yes, we've come a long way with additive manufacturing from Joe's presentation, for example, but there's still a lot to be done, right? And so there's still a lot of fundamental research that has to be done, and that requires the federal funding investment, and it has the potential to directly impact a lot of people as well as many other businesses besides those that just adopt additive manufacturing.
Great. Well, that's terrific. So we've got an example up here, national laboratory, we've got private sector companies, national manufacturer, and the university. They're all pieces of the ecosystem that we need to wind up moving forward. We wind up having public sector investment in this innovation. I guess the next question is for John Olszynski. Your organization, American Makes, plays a unique role because you tie these together to wind up really moving forward additive manufacturing as a technology for Youngstown, for Ohio, and then across the nation as a whole, and really having that nested connections of communities and having that impact. I wonder if you can make a few comments on your experiences in doing that and the role of doing that as a public-private partnership.
Absolutely, thanks, Mark. So one of the key roles that we actually serve is just that. We're trying to build the bridge between the work that's being done in national labs, being done in academic organizations that is working primarily on basic research and connect it with the commercial sector. So how do we get to the point where we're able to take what is good that is coming out of laboratories and out of the academic institutions and pull them forward and push them closer to commercialization? And that's really what the institute model is set up to do. So we, American Makes, are the first innovation institute, if you will, focused on advanced manufacturing. We were founded just over 7 years ago now, so we've been at this for a little while, but we've been putting all of our energy in trying to, what we love to call the valley of death, but that place between the basic research community and commercialization. And there's a couple of great examples up here of how that is taking place. But that's really where we're spending most of our time, trying to understand what those needs are and trying to push that back into the research community so they understand what areas to concentrate on. So we do a lot of work within the Institute working with industry representatives to understand what are the needs of the community, how do we build capabilities and start to get to the point where we are building ecosystems for the technology so that we're ultimately achieving our goal. And the goal of all of the institutes is really reinvigorating American manufacturing. So that's really what it's all about. That's why we're all here. That's why they were established years ago. And how we're doing that is by, a relatively simple phrase, convening, coordinating, and catalyzing. So we're working to bring the community together around the problem space, understand what that is, organize the needs, and then take action. And that's being done all around the Institute, but we're trying to serve as this organizing function, if you will, so that we're leveraging investments wherever they may be coming, whether from the public sector or the private sector, and doing as much good as we possibly can with those particular investments. A few of the things that we're specifically working on at the Institute are really focused on that ecosystem development, and that is both the kind of the supply chain side, if you will. So one thing that was talked about a little bit as we earlier in the day is what are the capabilities of the supply chain. There's a lot of unique solutions that are out there and a lot of capability, but the kind of manufacturing base hasn't caught up. They haven't really embraced the technology. Folks like Cincinnati are trying to, that are experts in conventional manufacturing, if you will, and they're becoming involved in additive manufacturing is really helping move that along. And the more we can get folks from the, I'll say more conventional manufacturing space involved, we're able to continue to grow the ecosystem. So a lot of what we're doing locally within, kind of the Youngstown, Pittsburgh to Cleveland region is try to prove out some of those models. So there's a couple of really interesting programs going on that are focused on supply chain development, focused on programs to specifically address needs. So these are both examples of some relatively simple problems that the Air Force is facing in their ability to sustain aircraft. So we're trying to build the ecosystem that can address these problems so that we're able to answer the needs of our Department of Defense customers. So we work very closely with those folks. Another big piece of this is the workforce and education component, and that's everything from energizing the elementary schools and middle schools, and there's a lot of momentum going on there, so that's good. But how do we work on reskilling our workforce so that they're able to take advantage of these new technologies, where they're able to potentially switch careers into something new? That's not, historically, that was not something a person that's been involved in the workforce is too interested in doing after 30 years of moving in one direction. Well, the reality of that is we're having to do that. Additive has the potential to provide a lot of opportunities there. So there's a lot of energy going into the education and workforce development space. And then, how do we catalyze this activity? And for 7 years now, we've been working on taking very specific actions to fund research to folks like those at the table here to make advancements. Some of those have turned into great success stories where a boutique solution of a couple of researchers out of an academic institution have been funded on a project at the Institute, and ultimately that got to the point where those are commercialized and available as a product at a person like an Autodesk or one of the folks that play in the design engineering software solutions, but they're readily available. So they go from a few folks, maybe a couple of people at the table understanding, to being available to the masses. And that's really what we're trying to do, get to the point where the technology becomes available across the community and really available for everyone to take advantage of.
Great, thank you. Well, we're going to move to a little bit more of an open dialogue at this point. Going to try and take at least one question from the audience in a minute or so, and so a little bit of time to think about that. But before we move forward, I want to say what I'm hearing over and over is people are talking about the federal investment really making it possible to build out partnerships at different places. And we have, what I find fascinating is we have places all around the country that are popping up as areas of excellence around additive manufacturing. And this is great to wind up seeing because we need more of that across the entire country. I know you work with, say, El Paso in one place. I've seen centers of excellence out in Pleasanton, California, up in Minnesota. I know down in South Carolina, for instance, GE built a partnership in their advanced manufacturing works with Clemson University, where I teach. So the students there can wind up actually working on designing and using those industrially scaled 3D printing equipment as a part of their research and as part of their education program. So that's exciting to see. All of these partnerships wind up building out the opportunity for people to grow. And that's what we wind up needing that public sector investment for. My question is, where do we wind up seeing those people coming from? So where are you either hiring people from? Where are you getting partners coming from? Are there pockets of excellence where it's just dying for more activity? Or do you wind up having it coming from all across the nation? So where are you seeing, I don't know, Randy, let's start with this. Where are you hiring people from?
We found some people in this, most of the people that I've hired that work at our Harrison, Ohio plant have come local because the University of Cincinnati has an additive manufacturing engineering curriculum, and Cincinnati State, which has historically been a 2-year associate type institution, they have additive manufacturing there as well. And kids are, like I said earlier, they started this long ago, and so they have an interest in it, and it's there. You just have to tell them, hey, we've got this. Oh yeah, that's great.
You're pointing out a really great point that I think we need to emphasize in public sector investment is investment in those community colleges. I know in South Carolina, for instance, at the Center for Manufacturing Innovation at Greenville Tech, you have people learning 3D printing side by side with learning CNC milling, and then going to work with manufacturers there. All of that getting that curriculum tied into higher education. So that's great. Craig, where are you seeing people coming from? You've got 7,000 visitors a year. What's the inbound from that?
Okay, so we have it at a variety of levels. We're fortunate in the fact that we have the ability to bring in high school students for the summer, undergraduate and graduate. And through working with 50 different universities, we have ample opportunity to get the exposure we need. So through an open competitive process, we can essentially we're fortunate, it's such a hot area, as you said, we can bring in as many summer interns as we want. We just try to make sure that we get a diverse pool, and we're very selective to give them the type of experience such that either they come back or they ultimately end up working with a lot of our industrial and other university partners with time. Our bigger challenge, Mark, and you're aware of this, is retention of our staff. Because with all these companies that come in, they recruit the staff. And we understand, we'll build for the country and so forth, but it's a dynamic environment. We've been able to retain a good portion of them, but that's more of my challenge. is the
So
retention.
I'm reminded on that of what a coach once told me where we had attrition one year. He goes, we don't rebuild, we reload. So, that's the mentality you have to have. Allison, where you want to see the students interested in this? In particular, I know for Clemson, this is an area we're looking at. How do we get more of our undergraduates as a public university saying, hey, this is something I want to get a master's degree. This is something I want to get a PhD in as well. And it winds up building that pipeline also of students. I don't know, what are you seeing at Penn State?
Yeah, I mean, I think we do have a lot of undergrads that, we really encourage undergrad research, so undergrads will join research groups and get exposure to various aspects. At SIM3D, which is our Additive Manufacturing Center, we have summer interns as well, so that gives people real hands-on exposure to the process. And then for our Additive Manufacturing and Design master's degree, we have a lot of people that are at Penn State and they sort of stumble on one of the additive manufacturing classes, and then they decide they want to get go on for the master's. But primarily, our degree program is attracting people from industry. So as I mentioned, we have a lot of industries participating, and they'll send their employees and they'll take the online classes, but they also do come for a hands-on component of additive manufacturing at SIM3D. So we're seeing a lot of interest from industry, but we also have several outreach activities in the community to get people, sort of younger kids, excited about additive manufacturing early on.
Yeah. And I know, John, thank you, Allison. That's exactly what I think we might have seen at universities. And it's exciting to see that happen. John, on this, I know that America Makes has been working on this issue as well, talking about people getting both either retrained or, for instance, people in their mid-50s that are executives wanting to come up to speed on additive. America Makes does a lot of that work, but it seems like you do a lot of the sort of train-the-trainer kind of stuff that no individual company is going to pay for, but the public sector really, that winds up leading it forward.
Absolutely, and we've early on we did a lot more, point solutions where we would go offer training because somebody, a small group needed training, and we're moving a lot more, and we're just seeing this from stakeholders that we need to get to the point where we're training the masses. So we've done a couple of relatively large online training programs with Deloitte, where the whole idea is how do you get your executive and leadership up to speed on the technology, and so they start to understand why we might use this technology, because there's just as many obstacles in the world of acquisition and how to buy something against the standard as there is against designing, a new component with the technology. So there's a lot of education that needs to be done there. We do a lot of work specifically with Department of Defense. We've done a large variety of different courses, specifically training soldiers in the field. How do we use the technology as a tool that can continue to make it an unfair fight, so that they're able to use a new technology, fix a broken down vehicle, whatever it might be, to provide a solution. So we've done a lot of training in that specific space, as well as trying to make sure our programs, and we're just kicking off a program with the Department of Navy right now, where we're training, kind of following an apprenticeship journeyman, master craftsman model, but the intention is it all has to be based on industry recognized credentials, such that when somebody exits out of the service, they're in the position that they can be hired immediately by someone from industry. So we're doing a lot of work trying to make sure the needs of industry are being met by the programs that are being developed.
Great, thank you. Do we got a question right in the middle back here? Can you say your name and what the question is?
Yeah, my name is Tanya Nuss. I'm with the House Science Committee. So I'm really pretty seasoned from Oak Ridge on the panel here, but I was struck by the fact that during the presentations you talked a lot about funding from these other federal agencies. So I was hoping you could talk more about the interest from the Department of Energy in 3D printing, I know they do a lot of work at Oak Ridge, but I was curious if others of you have partnered with them as well, and in what capacity?
Great, can I take this? That'd be good. So actually, before I was a faculty member, I went back, I actually ran the Advanced Manufacturing Office with the Department of Energy. So, truth and disclosure here, Craig and I have been working together for 15 years, not 10 years. On additive manufacturing, the work they've done around MDF, and from my perspective on that is that you simply would not have the private sector investment sustaining that if you did not have that core nucleus of public sector investment that's inside of it. It's the attractor. It winds up giving you the ability to reach back into the laboratory to all the areas where you do basic research, whether it's the supercomputers that you wind up having there to be able to do modeling. It was talked about how artificial intelligence and computer design is so key to this at this point. Having that capacity just right up the street. Whether you're able to wind up using neutron tomography, where you literally have a spallation neutron source, which for those of you who are not neutron physicists, is about a mile-long neutron source that is the brightest neutron source, I think, in the United States or in the world. And you use that for literally exploring these materials and understanding them. So my observation was you could not have this capacity to wind up just saying, oh, let the private sector take this and let them come together, and that would work if you didn't have that continued support of the public sector in the research that's going on today that winds up then partnerships that winds up building it. I don't know, Craig, if you want to build on that.
So, of course, I just, as we got into the additive area, it just so happens that Oak Ridge's core capabilities and materials, advanced characterization, neutrons, and modeling are the three key aspects that you have to have if you're ultimately going to be able to commercialize additive manufacturing. While our time here is short, as we got into additive manufacturing deeper and deeper, really these scientific tools are going to enable us to ultimately qualify, and this was spoken to a little bit, a part size of one, the coming of the data analytics and so forth. We're now at the point where we're prescribing 3 dimensions our microstructure. And that's really interesting. We're almost reinventing metallurgy. Did I see this coming 15, 20 years ago? No way. You have to get in and you actually have to be doing this to understand where the shortcomings are and where we really need to be focusing a lot of our fundamental work. That, while we can do things like control microstructure, it's also important to back up and say, now we can make uniform properties for materials throughout a build, which doesn't necessarily happen inside of a build. So a lot of that fundamental science is really driving this for ultimate commercialization. And another thing that hasn't been spoken to, most all these systems are run open loop, so they don't have closed loop controls. So you kind of get what you get. We image every single layer. We know spatially and temporally everything about a build. So we can actually, as we go through, we do the advanced characterization, be it tomography, be it neutrons, we know exactly where that was built, why, what happened, and so forth. So every single experiment you run, you get smarter and smarter and smarter. We're in the middle, and this is public knowledge, we're printing small, modular type reactor structures and things like that. And it's more about the data than actually the additive manufacturing, if you can qualify the data. A lot of what's been done commercially by GE, they're qualifying the process. Ultimately, we want to qualify the data. Because all the data is there. That's the beauty of additive manufacturing. I get to dissect this and grow this in 3 dimensions. So I get to look at every single thing as it's being built. It's not like a casting. So there's tremendous work being done.
And I'm going to turn it over to Randy in just a second, but also answering the question. I just, further federal investment, I just came back from taking a sabbatical in Europe on a Fulbright faculty exchange. Looking at just this question, how do you wind up innovating and going to a number of research facilities around Europe, saying what's working there, what's working here. You have 2 things in the United States that are absolute gems. One is our education system. There is nothing like that for technology innovation in the world. Other countries want to adopt it. Students want to come here for a reason. The market forces say that is an incredible gem. Those are public sector investments. That doesn't happen by itself. The other part is our national laboratory system, having that core science and technology. I think one of the things that Craig and the manufacturing demonstration facility have really looked at is saying, how do we build a unique structure around it? So I encourage you to actually, anyone in this room, to go visit them, add to that 7,000 visitors a year. The facility is actually located outside the main campus of the National Laboratory, and it's intentionally there to make it much more like a business industrial park where you work with your next door neighbor on things. It also winds up having a completely different flavor, being much more applied, trying to get the job done, but it's adjacent to the National Lab. And what I like to think about this, relative to, there's a bunch of ways we can stand up consortia and do public-private partnerships on it. This is really kind of a model for a uniquely American solution instead of trying to adopt other people's solutions. Let's look at what we want to having as a nation, where our universities and our national laboratories can work together. We can talk about it in terms of like a hub and spoke model, a range of things. I'm sorry, Randy, I'll turn it over to you now. If you can comment on how you sort of use Kratos to transform your company every day, or use the public sector message. That are, by the way, teaming Kratos, right?
How we've used Kratos to transform.
Yeah, how it's transformed your company.
Okay, well, the main thing is that in a machine tool company, it wasn't natural for you to have R&D outside of the products that you're developing or the processes you're developing for the machine tool industry. We had metallurgists that worked on our tools for our press brakes. We have an additive manufacturing line that we've had since the 1960s called powder metal compacting. Many of the parts that are in your cars today are powder metal parts, connecting rods, valve guides, gears for transmission. We've been in that business since the 60s. So we had that basic technology. But that is taking powder and dumping it into a cavity and then putting force underneath it, mechanical properties. There's chemical properties to it too, but we had those scientists behind that. But with the downturn in the economy and the U.S. sort of losing its edge in the machine tool business, we were not able to maintain that talent. We basically had talent that produced our equipment, designed our equipment for customization for customers. So we knew that we did not have the science horsepower behind us, that we had to reach out to somebody that did. And we knew Oak Ridge. I mean, everybody knows who Oak Ridge was or is. And we needed their partnership. So we established a collaborative research and development where they take our machine and they put features on it and they experiment with it and they come up with concepts. And then it's our responsibility as part of that creative share is that we take that and we commercialize it. And what does commercialization mean? It means turning it into a product that the person that's using the machine is not a scientist. They don't have the education level that we have at Oak Ridge. So we have to, I don't mean this sarcastically, but we have to kind of dumb it down a little bit, because a lot of the operators that operate our machine tool are people that they were working at McDonald's at one time, and they got into the industry because the industry came in and expanded in town. They don't have the scientific knowledge to do the little things that's required or the scientific things that are required to make a quality part. So our responsibility is to take the science and commercialize it. And without a creative, we wouldn't be able to do that. We would be guessing. And with guessing comes failure, and failure becomes time. Oak Ridge is able to fail fast first and fail often to get done quickly. And then we capitalize on that. And that's what a creative is. It's a collaborative research and development agreement where they come up with a principle, we commercialize it.
Well, thank you very much. I'm sorry to say this, but I don't want to take any extra of your time. I know we said we were going to be closing off here. I'd like to invite Taffy back up to make some closing comments. If you all individually have any questions you want to ask of the panelists, I'm certain we'll be happy to wind up continuing the discussion. So,
Well, thank you, Mark. Thank you to our panel. Thank you to all of you for coming here today. I think the answers to the questions are pretty clear. We do need to have funding in the agencies we've talked about, in DARPA, in Office of Science, DOE Office of Science, in NIST, in NASA, National Science Foundation. These are the fundamental agencies that fund the programs that create the science and technology that enables our society to be what it is today. So we're operating under a CR right now. I'm sure that you all will be continuing resolution for those who don't know what you'll be looking at the funding levels for these agencies, and I really encourage you to think long and hard about how important these investments truly are. Before you go, I'd like to recognize over here, we have a 3D printer, a desktop 3D printer that was brought by John Osinski and his partner Joe. And we're making today, right now, in front of your very eyes, little 3D printed objects, a donkey and an elephant. I wonder why. But look, we really appreciate it that you're here. Again, I commend you to pick up this brochure that's outside the door. Take a look at it, study it, think long and hard as you deal with the funding issues, and have a great day. Thanks for coming.